Hey, welcome everybody to lesson 2, piecewise functions of the functions unit. So a piecewise function, they're not really that difficult. They're pretty much just evaluating a function, but there are certain rules. We'll get into that in a minute. What piecewise functions are used for? When you're first seeing these in Algebra 2, they're used, if you ask students, to make you go crazy. But that's not the truth. The truth is what they're used for is if we have different boundaries that we have to work with inputs. Where you might see a piecewise function, if you ever look at like stock markets or anything like that, those types of graphs, you'll see some pretty weird looking graphs that you're like, I don't know how I would ever get that. Well, we can look at little sections of it and create piecewise functions from those particular graphs. There's a lot of other uses for it. Like I said, anytime that we experience restrictions, we can create a piecewise function from it, which leads us into what a piecewise function is by definition, right? So a piecewise function is a function written with two or more expressions and rules restrictions. And we have an example of what that looks like here, right? We still have the traditional f of x equals, but now they're giving us these different situations. They're saying two parts. We have the expression itself that we would evaluate, and then we have the restrictions and rules. Right? These rules restrictions can be written a lot of ways, but generally they're written like this, telling us where to begin, where to end for this particular expression. For this example, any number x that's less than -2, so -2.1 or -3, -4, everything, right? Anything less than -2, we would want to evaluate in this particular piece of the function. If we're using a number that's equal to -2 or in between and equal to 3, so -2, -1, 0, 1, 2, and 3, and all the stuff in between, any of those numbers that show up would be evaluated right here in x squared. And then finally, anything that's larger than 3, right? Not including 3, because 3 was up here, but anything larger, like 3.1. Okay, that type of stuff would all be evaluated right here. So you have your expression, and then these are your rules or restrictions. Now, sometimes they can do something inventive, right? They could maybe tell you all evens. You know, if x is even, they could say if x is a multiple of 5, right? There's all sorts of different things that they could do, but generally speaking, you're going to be seeing them written this way. Okay? One last thing before I get too deep into the problems. Last year when I taught this, and this year being 2019, so 2018 when I started teaching this lesson, I started drawing this out, and it really helped people. And I had never done this until last year. Okay, so what I'm going to do is this. I'm going to draw a little number line, and I'm going to look at my restrictions, and I'm going to draw what those numbers are. Right? I have a -2 here, -2 to 3, which is right here. Okay, and then I'm just going to make some quick little notes. Right? From here that way is x plus 2. From here to here is x squared, and then from here that way is -3x. Now what I just did here was I just drew myself a little reminder map of where I need to plug things in. Yeah, I can get it from looking at it here because I've done this a bunch of times, but if you're new at this, just draw out a number line, figure out where things are, and then just draw in the formulas. Then you know exactly what you're using or what you need to plug in, right, when they ask you to use it. So using this same example, they want us to use that function above and evaluate a whole bunch of different points, right? -4, -2, 0, 1, 3, and 5. The last lesson, when we saw all these, we just plugged it into the same function. We don't have that luxury here. We have to figure out where these numbers belong. Again, you can either look at it directly from here to here, and you could say, well, I know -4 is less than -2, and then just evaluate it where it belongs. Or if you use this little line here, like I did, you can identify it as well, right? I know -4 is on this side of the number line from -2, and that falls into this expression. So when I want to do f of -4, I'm using this expression here. -4 plus 2 will give us -2. So if we plug in -4, we get out -2. Okay? Where this also helps, drawing this line, right, I have the little points and the little opens over here. When I see -2, I can see where it's lined up. Sometimes students forget what these symbols mean. During the middle of a problem, it happens. It's kind of weird that it happens, but it does. So if you forget what these things mean, maybe drawing it out this way might help. Now I know -2 belongs to this x squared expression. -2 squared becomes +4. So we get -2, +4. 0, right? 0 is somewhere in between -2 and 3. So again, I'm still using x squared. 0 squared is 0. So 0, 0 would be our solution here. 1 is right here, so it's still in the x squared. 1 squared is 1. So we get 1, 1. 3, again, 3 lines up in the x squared function. 3 squared is 9. So we get 3, 9. Finally, 5. Well, 5 is way over here, right? So that means 5 belongs to this -3x function. So I'm going to do 5 down here. -3 times 5. -3 times 5 is -15. So -3, oops, sorry, comma. That should be 5, -15. Oops, I started writing the -3. I wanted the 5, right? Well, we evaluated. So, not that bad. If you draw out that number line first, it really helps if you're having a tough time trying to do it directly from the function. So if you can't do it from here, do it from here. Okay? Here's a problem for you to try. Pause the video, write all this out, do your work, and then resume it when you're ready to check your answers. Alrighty. I'm going to first draw out our number line. It's giving us restrictions at -1. So here's -1 right here. It says if a number is less than or equal to. So I'm going to put a filled in circle and go that way. Less than or equal to, we're going to use 10 minus x squared. If it's greater than -1, so open from this side, that way we'll use 3x. The important part is that where this bullet point is. Everything else is just where it falls, right? -3, for example, falls over here. I know it's going to be that 10 minus x squared. Right? So -3, 10 minus -3 squared. -3 squared is 9. 10 minus 9 is 1. So -3, 1. -1, that falls right here, and it hits with this function, so we still need to use this 10 minus x squared. -1 squared is +1. 10 minus 1 is 9. So if we plug in -1, we get out 9. 0. 0 is over here, right? 0. In fact, 10 will also be over here. And then for some reason I threw in -4. We'll deal with that one in a minute. Let's do 0 first. So 0 belongs to the 3x function. 3 times 0 is 0. So if we plug in 0, we get out 0. What about 10? well, 3 times 10 is 30, so if we plug in 10, we get out 30. The last one, negative 4. Negative 4 is over here, so it belongs to the 10 minus x squared function. Again, we'll take care of negative 4 squared. Negative 4 squared is 16. 10 minus 16 is negative 6. So if I plug in negative 4, I should get negative 6 out. Okay. As far as the evaluating goes, it's just the normal arithmetic. You follow PEMDAS, PEMDAS, whatever. When it comes to figuring out where to plug it in, that's up to you. Do I want to continue to look back to here? Do I want to draw it out on a number line? I'm not going to tell you how to do it. I'm just going to show you the different ways that you could, different ways that people have had success with these in the past. Here's where things can get a little bit more tricky. Graphing. Okay? When you graph, it's okay for you to graph the entire function and then erase what's not needed. Okay? If you're good with graphing your functions, these can be a little bit easier. If you have more difficult time, you have to go a little bit slower. You might have to take a table of values and plug in and then evaluate and draw it that way. However you do it is fine with me. Trying to do these on a calculator can be very difficult because I have yet to find one that's really good at graphing piecewise functions. Plus, you can't use those kind of apps or whatever on your phones in school anyway, so you might as well learn how to do them by hand. We're going to do something very similar to what we did last time, because we already have a number line right here, right? This would be our number line that we drew last time. And they give us numbers, right? Here's 1, 2, 3, 4, 5, right? Negatives. So I can actually mark up here based off of where these particular things are. So I'm gonna take my time to do that right now. I notice at negative 2, I have a specific function, and I notice at positive 2, right here, I have a specific function. Now I could, in fact, I'm gonna do it in a different color, right? I know that once I hit this little dotted yellow line, that it's going to probably look different, most likely. So, let's start with the first equation, right? X squared. I'm going to ignore this part right now, just the x squared. I know that x squared, if I was to do the entire graph, I'd be at 0, 0, negative 1, positive 1, negative 2 would give me out positive 4. So I know that there would be a point right here. These points here and here, I don't really need them. I drew them, right? It's okay to graph the entire function, but the zone where x squared lives is from here over, right? Less than negative 2. So what I'm concerned with is what it looks like from here on out. If I was to plug in negative 3, I should be getting a 9, so it should be coming in like this. All right? And because I'm allowed to include negative 2 in this function, I know that that should be a filled in circle. So my final solution, I have a point right here, and it's going up like this. I don't need to draw the rest of this over here, because it only stops at negative 2. Now from here, I want to draw the rest of it, right? Let's look at this function. In between negative 2 and 2, not including, so on these lines it should be open circles, I'm going to have this graph. Well, what does this graph look like? Here's my y-intercept. I know I start here at positive 1, and then I have a slope of 3 over 2. 1, 2, 3, 1, 2. Okay, that landed on the line, so I'm going to make sure that it's an open circle. And if I go the other way, 1, 2, 3, 1, 2. Hey, look, that also lands on the line. I'm going to make sure that's an open circle there as well. And because it's a straight line, we'll connect these. If you don't have a straight edge, just draw it as straight as you can possibly draw it. I'm not a robot, neither are you, so do the best you can. Finally, we have negative x for anything greater or equal to 2. So we know that we're going to be on this line, right? And wherever we hit this line, it should be a filled-in circle. But I need to draw in negative x. Well, this is another linear function. Our y-intercept is 0, so we would have a point right here. And our slope is down 1 over 1, down 1 over 1. So I drew it out on this side, kind of, right? I just kind of penciled it in. And this is where I know it picks up, is right here. And it's going to continue to follow that pattern, right, down 1 over 1, so I can see where it's going. I just have to draw that in. And again, make sure that I fill that in because it's included. That's how you draw a piecewise function, right? We drew parts. Right, we drew parts that we might have needed, we drew parts that we might not have needed, and we erased them as we went along. Take your time when you do these. You have one right down here. It's not the easiest thing in the world. If you need to use a table of values or something, go for it, okay? Pause the video and try this out. Resume when you're ready to check. All right, let's see how you did. First, we have our markings at -2 and at +2, right? Those are the places where they mention our restrictions. If you drew a dashed line, we know that it's going to have some different looks in these little zones, right? And anything that lands on this line for this function should be filled in solid, and then for these functions we know it's going to be open circles. All right, so I'm going to graph this line right here, and I'll only include all the stuff less than -2. So let's graph this first. -1 would be my y-intercept, has a slope of 1/2, so it would be up 1 and over 2. On the other side, it would be down 1 and backwards 2. So actually, I can see where it's hitting my function right here. It should be an open circle, and it's going to continue this way. So, from -2, anything less, so from here this way, it's going to follow that line. Here we have between -2 and +2, including both. Well, -x² plus 3. Well, I haven't seen these too often, so maybe I might have to evaluate, right? If I was to actually plug in -2. -2 squared is 4, but then we have this other negative on the outside. -4 plus 3 is -1. So we got -2 comma -1. All right, -2, -1 puts a point right here for us. Maybe I have to try another point. How about if I was to do +2, right? That's one of our points. +2 squared is 4 times negative, so that gives us the same thing. So I know we end right here. What if I plugged in 0? 0 squared is 0 plus 3, so we would have gotten 0, 3. And I can see, generally speaking, what this is going to do. It's a parabola, right? So it's going to go like this. I could test -1 and +1, right? -1 squared is 1. -1 plus 3 is 2. So -1, 2, and that would give us the same for +1. Did we have to do all of that for this? Not necessarily. If you know what this shape looks like, if you know what the function looks like, draw it. If you don't, do some table of values. Grab a calculator, let that help you out. Maybe graph just this on the calculator and then zoom in. Hey, if it works, it works. Finally, anything greater than 2, not included. So we should have an open circle for this particular thing when it hits the yellow line. Let's graph this line. First of all, our y-intercept is up here at 5, and we have a slope of down 2 over 1, down 2 over 1. So here's where our function hits, and then it continues like this. So open circle, and there is your piecewise function. How did you do? Did you do all right with these? If you didn't, maybe come in with some questions, maybe rewind these and check them over, see where you might have made some mistakes. Hopefully you did okay with the evaluation portion of this. The graphs are much more difficult because it's something that you haven't really done too much of. So bring your questions into class or leave them as comments, whatever you want to do, and I'll see you in the next video.